Hello students, this is Dr. Asifulla, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes under Hennur Bagalur Road, Bangalore. Let us discuss today's topic, limit of a function using L'Hospital's rule. Now let us discuss the problems on limits of the form infinity minus infinity, 0 into minus infinity, and so on. So let us select the third question. And solve. First step is consider the limit as k. Let us call the limit as k and check which indeterminate form it will take. For that, we'll put the limit as x is tending to 0 wherever x is there, which we have done in the step. We all know any finite quantity divided by 0, that is a divided by 0, is infinity. And here we know tan 0 is 0, tan 0 is 0. So cot 0 will be infinity, because cot is nothing but 1 by tan. Cot is nothing but 1 by tan. So we can make it as infinity. So the form which we got on putting the limit is infinity minus infinity, which is indeterminate form. Now the thing is, once we get this type of indeterminate form, we cannot apply L'Hospital's rule. We cannot apply LH rule, because LH rule is applicable only for 0 by 0 and infinity by infinity. So we need to manipulate this function. To bring the function to this form or to this form. Let us manipulate this function now. Yes, we have taken here k is equal to limit as x is tending to a by x we have kept as it is. Here we can write this cot of x by a as cos by sine. Cos of x by a divided by sine of x by a. I think we can expect that the very next step is to take the LCM, because we need to combine these two terms and make it one. We need to combine these two terms and make it one. For that, we need to take the LCM. Let us take the LCM now. Yes, we have taken the LCM is x into sine of x by a. We have taken the LCM here. Then in the numerator, this gets multiplied here and x gets multiplied here. Yes, here and here we get x into cos of x by a. Yes, we have manipulated the given function to this form. Now let us check once again which indeterminate form we will get on substitution of the limit. Here by mistake I have taken a here, this is 0, x is tending to 0 is this, x is tending to 0. Now let us put the limit and check. Yeah, we have put wherever x is there, we have put 0 as the limit. Here, here, and here, as well as in the denominator here and here. You can observe we have taken 0 wherever x is there. Now let us see what will be the answer for this substitution. We all know this sine 0 is 0 because 0 by a is 0. Therefore, sine 0 value is 0. So this term goes to 0 here. And anyhow, this is 0. So 0 into anything is 0. In the numerator, we got completely 0. In the denominator as well, 0 into this will be 0. So it is 0 by 0 form we are getting. Yeah, after all these simplifications, we get 0 by 0. Yes, after manipulation, we got the form which takes 0 by 0. Now, this form is applicable for LH rule. For LH rule. So let us apply LH rule to this and proceed. We say applying LH rule to equation number 2. We all know LH rule means that differentiate numerator and denominator separately, then apply the limits. Let us do so. Yes, I have taken the equation number 2 here again. Now let us differentiate the numerator separately. I have written the limit as x is tending to 0. Actually, this is 0. By mistake, I have taken a. This is 0. Here we have taken x is tending to 0. Fine. This constant a as it is. Yes, we have kept a as it is. Here, if you observe very carefully, this is a function of a function where sine is one function and x by a is another function. Let us differentiate this sine of x by a by using chain rule. Differentiation of sine of x by a, first thing it will become as cos of x by a. Differentiation of sine of x by a is cos of x by a. But again, inside we have one more function. We need to differentiate this again. When we differentiate x by a, you can see this 1 divided by a is a constant. 1 divided by a is a constant. We have to write as it is. And then differentiation of x will be 1, which we have not displayed here. Differentiation of x is 1, which we have not displayed here. So this is how we applied the chain rule to differentiate sine of x by a, and we got this. Now let us proceed for the next term. This minus we write as it is, minus. Here it is clearly visible that we need to apply the product rule first, because it is the product of two functions. X is one function and cos of x by a is another function. Now let us use the product rule now. First function as it is, differentiation of second function. When we differentiate second function here, it is clearly visible that we need to apply the chain rule, because cos is one function and x by a is another function. Let us apply the chain rule now. First differentiation gives minus sine of x by a, because differentiation of cos is minus sign. Yes, you can observe here differentiation of cos is minus sign, we have written minus sign. Then again differentiation of x by a is 1 by a. Differentiation of x by a gives 1 by a, we will write here because the differentiation of x is 1 and 1 by a is a constant. So this is the term which says first function as it is and differentiation of second function. Then the product rule says plus second function as it is. Second function as it is, differentiation of first function x. Let us differentiate x now. If you differentiate x, you will get the answer as 1, which we have written here. Differentiation of x is 1. Divided by, we differentiate the denominator as well. Let us differentiate the denominator. Again, you can see to differentiate the denominator, you need to use the product rule. X is one function, sine of x by a is another function. So we write first function as it is, differentiation of sine of x by a. Again the chain rule, it gives first cos of x by a into differentiation of x by a is 1 by a. Plus second function as it is, and the differentiation of x will be 1, which we have not displayed, I think. Yes. Now let us go for the next step. In this step, few things will get cancelled. You can observe this a gets cancelled with this a, and we can multiply this minus sign inside here as well as here. Let us simplify these two things. After cancelling a with this a, we have written cos of x by a, and we have multiplied minus into minus plus, we get x into 1 by a sine of x by a, we have written here. Let us multiply this minus with this plus, we get minus cos of x by a divided by this completely as it is, no change, nothing will get cancelled in the denominator. Now in this step you can observe, in the numerator cos of x by a and minus cos of x by a gets cancelled. So after cancelling these two, let us write the next step. We have written here. Yes, we have applied the LH rule and we have simplified till here. Now what next? We need to apply the limit and check whether we get finite answer or not again. Let us apply the limit now. Here I have taken the same step from this previous slide. Let us apply the limit now. Okay, here we are rearranging the terms again. Let us rearrange the terms first. We have written 1 by a outside. We have combined x and sine of x by a here. And from the denominator also, we will plan to take 1 by a as common, so that this 1 by a we can cancel. Let us see. Yes, we have planned to take 1 by a from here and here. Even though 1 by a is not there, if you are planning to take 1 by a from here, it will be like a by a. You have to divide and multiply by a first. Then if you take 1 by a outside, what remains here? X into cos of x by a remains here. Then plus what remains in the second term? A into sin of x by a remains, because this denominator a has been taken out as common. This a and this a has been taken out as common factor. Now let us write the remaining things here. X into cos of x by a plus a into sin of x by a. Now you can see this 1 by a and this 1 by a gets cancelled. Yes. So this is what further simplified step before we apply the limit here. Some more things have been simplified till here. Now let us apply the limit. Here we are going to apply the limit and check what will be the answer. Yes, we have applied the limit as x is tending to 0. You can see wherever x is there, we have put 0. In the numerator, because of this 0, whole numerator will become 0. And here in the denominator, 0 into cos is 0. In this second term, because this is sin 0 is 0. So a into 0 will be 0 again. The whole denominator is becoming 0. So it is again 0 by 0 form. We have written it is again indeterminate form, which is of the form 0 by 0. So we need to continue with LH rule now. Let us apply LH rule again to this limit. That is, we are going to differentiate separately the numerator and the denominator. Here we say applying LH rule to equation number 3. Let us apply the LH rule now. I have taken the equation number 3 here. To differentiate this numerator, we need to apply product rule. Let us apply the product rule now. First function as it is. Differentiation of sin of x by a. We need to use the chain rule as we have discussed earlier. Differentiation of sin will be cos of x by a into differentiation of x by a. If we do, we get 1 by a. Then plus second function as it is. Second function as it is. Differentiation of first function. If we differentiate x, we get 1. Yes, we have completed the differentiation of numerator using the product rule. Now let us differentiate the denominator as well. Term wise, we need to differentiate. If we start to differentiate this term, in this term we need to go by product rule first. In this term we need to go by product rule. Let us do the product rule for this first. First function as it is, x as it is, differentiation of cos will be minus sin of x by a. Differentiation of cos is minus sin of x by a into differentiation of x by a will be 1 by a, which we have written here, plus second function as it is into differentiation of x will take you 1. 1 we have written here, differentiation of x. This completes the product rule for the first term in the denominator. Product rule for the first term in the denominator, it is done. But again, we need to differentiate this next term. In this next term, a is a constant, we need to keep as it is. differentiation of sine of x by a using the chain rule. We need to do differentiation of sine is cos x by a, cos of x by a into differentiation of x by a will be 1 by a, which we will write in the denominator here. 1 by a will write here now. Let us write now. Yes, we have written 1 by a here. This here was a constant which we had taken here from this. And this denominator has come from the chain rule as 1 by a. Okay, now let us further simplify. The numerator we have written as it is. We have taken the numerator as it is. So let us simplify the denominator. When we multiply this minus here, it gets minus x into sine of x by a. This cos of x by a we write as it is. Here in the last term, you can see this a and this a gets cancelled. What we get is cos of x by a. Cos of x by a plus cos of x by a will be 2 times cos of x by a. Anyways, we'll substitute the limits now as x is tending to 0. If you substitute the limit as x is tending to 0 here, because of this 0, this complete term goes to 0, which we have written here. And when you put x is equal to 0 here, and we know sine of 0 is again 0, which we have written here. Now in the denominator, let us see, when you put x is equal to 0 here, 0 into anything is 0. Yes, we have written here that 0. If you take x is equal to 0 here, cos of 0 is what? 1. And here if you take x is equal to 0, cos of 0 will be again 1. You can see here we have written. Now let us see what we are getting. Can you see very clearly it is 0 in the numerator, it is 0 divided by in the denominator what you have 0 plus 1 is 2. We all know 0 divided by any finite quantity is 0 only. 0 divided by any finite quantity is 0. So 0 is a finite, no problem. 0 we may get the answer as 0 in limits. But we should not get the answer as 0 by 0 or infinity by infinity and all. 0 is acceptable because 0 is a finite quantity. So we have reached our answer, which says the limit of the given function is 0. So let us move the slides now. Yes, it is for next step is 0 by 2. Very next step is k is equal to 0. So here we got the answer as 0 and we stop our problem.